Hey everybody, and thanks for tuning in to the Daily Space Weather Show. I'm your host, Dan, aka Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. We're showing 24-hour videos here to start things out. This is the past 24 hours, obviously, of the closest star in ionized helium and ionized iron. Are you ready for the coronal mass ejection impact? NOAA is forecasting it to show up as early as around midnight. So first thing, tomorrow on the 19th, you may be able to see the aurora at mid-latitudes in the early morning hours. So let's talk about sunspots first. We've got at least 3 new named sunspot groups. One just to the east of the Earth's scale is the newest one to rise around the eastern limb. It's exciting times for space weather. And we're not even at solar maximum yet, and we'll show you why momentarily here. Here's the northern hemisphere. We've got some huge plasma filaments that are definitely noteworthy. Some of them already have names, like the Scott McIntosh filament and the Reed-Timmer filament. Here's a brief look at the equatorial view, and you can see part of the Eugene Bagashov filament, which has partially ejected and partially repositioned itself. It's down there in the southwestern hemisphere. And here's a great view of that area. You can see that CME happening, that coronal mass ejection. It is not earthly directed. And again, you can see part of that filament moves itself to the east, making it stay in view for a longer period of time. So that's fantastic. And more about plasma filaments a little bit later in the video. Oh, here's a close-up of this one, by the way. There's the Eugene Bagashov filament, named after Eugene the philosopher. More on his YouTube channel a little bit later in the video. So that's what's going on. Let's take a look at sunspots and magnetic fields. Before we do that, take a moment to press the like button. That's okay, we'll wait. Seriously, press the like button. By the way, thanks to our new viewers. Thanks to everybody who tuned into yesterday's content. Seeing well over 5,000 views on yesterday's daily space weather videos. So thanks to everybody who has discovered the channel. Congratulations on realizing it exists. It's only the world's most comprehensive daily space weather show and most detailed solar imagery. We also throw in meteorology segments because, well, we want you to be able to forecast your own weather, whether it's in space or whether it's on Earth. You too can forecast your own weather. There is plenty of data out there for you to do it. So if you want to help out the channel, and we do need your assistance, please visit our links at smashomash.com. And welcome to the Neo Renaissance. We launched a massive web ring to help empower people like you, our viewers. So thanks to each and every one of you. Here's the past. That is yesterday plus today, the September 17th and September 18th to date. So we've got 3 new sunspots to get names today. This one down here in the southern hemisphere. That's one. This one down here in the southeast hasn't been named yet. That'll be 2. And then up here, a new one just rose. That's 3. So 3 new named sunspot groups. Just a minor uptick in solar activity for the past 24 hours. There is yesterday plus today in colorized magnetogram. You see the rapid growth of this sunspot. It has been stable for the most part over the past about 24 hours. Let's take a brief look at what's going on planet Earth in terms of volcanoes. Mount Mayon is continuing to erupt and produce a 9,000-foot ash plume over the Philippines. Kilauea's lava supply has ceased, so the Halema Uma'u lava lake there is now shrinking. Kilauea not really erupting anymore. Popocatépetl in central Mexico exploding, flight level 220. It's a 22,000-foot plume of volcanic ash. One of my bucket list volcanoes, Popocatépetl. Say it aloud, folks. Go ahead. Popocatépetl. You can say it. Sanchaguito exploding in Guatemala, flight level 150. It's a 15,000-foot ash plume. Fuego, 16,000-foot ash plume as it also explodes. Revenador exploding in Ecuador, flight level 150. And Sabancaya is the world's largest ash producer at the moment, located in Peru. It's a 26,000-foot ash plume, flight level 260 over Sabancaya. Next, earthquakes, and it's been quite calm over the past 24 hours. There are the past 90 days conveniently put in bar graph form for you. And really, the number of 7 magnitude earthquakes have been kind of low over the past 90 days, but here are the quakes of a 5 or greater magnitude. So just scrolling up the list here, starting yesterday afternoon. First one on the list here is a 5.1 at the South Sandwich Islands region. That was at 22:54 Universal Time yesterday evening. Second 5 or greater magnitude quake was in northern Italy. That one was at 3:10 Universal Time this morning. Looks like it did cause a little bit of damage. Of course, there are many, many old historic buildings located in Italy. Besides that, that's it. Only 2 5 or greater magnitude earthquakes over the past 24 hours. And let's get back to space. Again, you can forecast your space weather, and we empower our viewers to do just that. We go through all the data that I wanted to look at when I discovered that there was a niche when it came to daily space weather content. Nobody's doing it, so rather than complain, I figured, I guess it's my job. So here you go. The past 24 hours on ionized helium, 304 angstroms from the Solar Dynamics Observatory. And you may see plasma filaments, coronal holes, active regions, and coronal mass ejections. Let's also show 171 angstroms, the house favorite wavelength. Gotta have it. And there you go. So that's what's been going on, and let's talk about some space weather stats here as we bring you a holistic view of what's going on in terms of the weather from the solar surface all the way down to ground level. 10.7 centimeter radial flux is at 145 solar flux units. It comes from this area where my pointer is. The upper chromosphere and lower corona, the transition zone, is where that radial flux is emitted, and it goes up and down with sunspot number. As you can see on this 1-year graph, the black line is the radial flux and the red line is the sunspot number. So a little uptick there. 145 solar flux units is the current 10.7 centimeter radial flux. And let's talk about solar cycles. So solar cycle 25 has already vastly exceeded solar cycle 24, and it's a long way to solar maximum. I mean, the NASA forecast for solar maximum isn't until around June of 2025, so we've got well over a year to expect to see solar activity increasing. So that's the radial flux progression from about 2005 until current day. And here you'll see how directly proportional sunspot number and radial flux are. There is the sunspot number progression. Again, solar cycle now vastly exceeding solar cycle 24. Again, expecting June 2025 there for solar maximum. Now, as far as the Space Weather Enthusiast dashboard forecast here, like I said, NOAA is forecasting geomagnetic storm conditions to begin. That CME expected to arrive around midnight. So first thing tomorrow morning, expecting to be right into geomagnetic storm stages. So that's pretty exciting. And just so you know, folks, we could have a KP8 from this. It all depends on magnetic field orientation and strength. So it's very difficult to forecast how strong a geomagnetic storm will be. What the effects will be on your location do depend on whether it's day or night time, your latitude, and again, magnetic field strength and orientation. Also, the plasma speed and density are a major factor in how strong of a geomagnetic storm it'll be. NOAA forecasting only a KP6 around 12 noon Universal Time tomorrow. Again, don't be surprised to see that all the way up around a KP8, as a large portion of that coronal mass ejection, as stated a couple days ago, is oriented directly toward Earth, give or take. The densest core is likely to miss to the south, but hey, see our previous daily space weather videos for more information on that. So here's the NOAA forecast for the CME impact. That's NOAA's Enlil spiral. Again, expecting it to arrive here at Earth. NOAA is expecting it to arrive here at Earth just after midnight Universal Time. So there you go. There's NOAA's forecast. And here's NASA's forecast. NASA expecting it to arrive a little bit later, and we would tend to agree with NASA. Tamitha Skov and I both said we're expecting it to show up after midday tomorrow on the 19th. NASA is expecting it sometime around midday. So This is going to be more consistent with our forecasts, and you'll find that when Dr. Tamitha Skov and I agree on CME impacts, they tend to be correct. So anyway, let's take a look at Earth's magnetic moment from space. We did have a brief period of geomagnetic storm conditions last night around midnight. Here are the past 4 hours of Earth's magnetohydrodynamic pressure. So this is the space weather modeling framework, our Geospace Magnetosphere movie. It depicts Earth's magnetic moment from space to about 12 Earth diameters. And things are pretty homogeneous there. So no major storm conditions. We only saw KP5, a brief period of geomagnetic storm, mainly caused by a brush by. We'll talk about it in a minute. First, Earth's magnetic moment from the ground for the past 4 hours. So many people did see the aurora. And if you want to share auroral imagery, you can join us on our Discord channel, which is linked at smashomash.com, a permanent invite link there. Or hit us up on Twitter. Just tag us in your tweet. Or you could hit us up on Instagram, for example. But yeah, Twitter and Discord would be the best places. There's the past 4 hours of Earth's magnetic moment from the ground. And one of the great ways to view where the aurora is going to be likely for North America is the geoelectric grid. So this geoelectric field map, it's going to show you actual induction when your area lights up. If you've got clear skies and a great view of the north, this might help to tell you when the aurora is likely to be visible, as these currents happen rather instantaneously. So there's your KP index. Like I said, we got into brief geomagnetic storm conditions. It wasn't much more than a magnetic field interaction. We'll talk about it here in a moment. KP 4.67 was the situation there, somewhere in between geomagnetic unrest and a G1 geomagnetic storm. Keep in mind we could get all the way to a G4 geomagnetic storm. I wouldn't be surprised at all to see a G3. I'd be a little bit surprised to see a G4 magnetic storm tomorrow. Again, we're expecting it to arrive, the peak of it we're expecting to arrive sometime around noontime, universal time, or later tomorrow. So here's the coronal mass ejection impact that we saw last night. It was very minor, and indeed we didn't really forecast this one. We expected this one to be missing Earth. But here is the impact. So right here, that is where the impact happened. You can see a shifting in the magnetic fields. That's the BTBZ, the total field and the vertical component of the magnetic field. The phi angle shifted at that moment. No change really in the solar wind density, a decrease in the solar wind speed, and a change in the plasma temperature. So that's basically just a brush by of that coronal mass ejection. And this brief period of geomagnetic storm was caused mainly by the magnetic fields. So a great example of how you can see not a big change in the plasma density or speed, but just the magnetic field orientation caused it to go to geomagnetic storm conditions. Very minor geomagnetic storm, and it subsided rapidly, which we documented last night on Twitter. So anyway, current situation is about 6.4 protons per cubic centimeter for the solar wind density. Solar wind velocity here just over 420 kilometers per second. The rest of that is pretty unremarkable. Continuing along, here are the GOES magnetometers, and they are not particularly perturbed. No major magnetic perturbations happening there for the GOES magnetometers. Expect some pretty significant fireworks in those. Probably on tomorrow's Daily Space Weather video, we'll be able to see some quite rapid variations there in the GOES magnetometers. Next, our top view ecliptic plane field plot. And this one is super important, folks. It's showing us the polarity of the heliospheric current sheet, sector boundary crossings, and also where fields are located on the solar disk. So, Earth is currently in a south pole current sheet. We can expect that to persist. North Pole current sheet is still a couple of days out, assuming that nothing rapidly changes, and occasionally it does when it comes to magnetic activity. And by the way, the heliospheric current sheet, what this is depicting, our top view ecliptic plane field plot, part of the Gong 2 data of the National Solar Observatory, what it's depicting is the Parker spiral, basically. The plasma that comes out of the sun, it puffs up around solar maximum, and it gets very small and sort of anemic around solar minimum. There's a great article on Wikipedia if you want to read about it. The Parker spiral, the heliospheric current sheet. It's what we're talking about there. And keep in mind it is not flat. So our top ecliptic plane field plot, it only shows the slice around the ecliptic plane. It doesn't show the whole heliospheric current sheet. Again, because it is a three-dimensional structure as the sun is constantly putting out plasma as it rotates. So here's our line of sight field plot. And here the solar B field is depicted in blue, the B field being the field that goes through the magnet, this magnet being the sun. Polar fields in green for north and red for south, and the photosphere magnetic fields there shown in grayscale. Quite a bit of magnetic organization on the Earth-facing portion of the solar disk for the past 4 days. And again, new sunspots just rose in the east. So here's our line of sight coronal hole plot. And we've got both south and north pole oriented coronal holes here on the Earth-facing portion of the solar disk. And how about if we take a look at those from the perspective of SDO before we move on to sunspots. So there you go. There's the past 24 hours in SDO 211 angstroms. So a few well-defined coronal holes there. They could cause some minor upticks in the solar wind of the Earth system, but they are small coronal holes, though well-defined. Anyway, next we'll move on to sunspots. And here is the sunspot situation. Again, we've got 3 new groups that will get names today. This one down here in the south, this one in the southeast, and this one in the northeast. Those will be known as 3436, 3437, and 3438. Likelihood of large solar flares not really that high at the moment, although keep in mind that can change suddenly. I think 3435 and also 34, oh, we already have 3436. So we'll be up to 3439 when this one in the northeast gets named. Again, at least 3 new named sunspot groups to receive names today. So here we're looking at sunspots from the SDO. That's the SDO continuum, the HMI instrument, superimposed with 131 angstroms, part of the extreme ultraviolet spectrum of light. And let's subtract the 131 angstroms. Now that we've highlighted those active regions, you can see this rather rapid growth down here of this group. That's a beta gamma class sunspot group. This sunspot down here, that's one of our other new ones. And of course the most recent addition is this one that just rose this morning up there in the northeastern limb. We'll also show the magnetogram, another 24-hour video from SDO. We do have multiple regions where we could see solar flares here. So the most likely one I would say is this group up here, followed by this group. So the northwestern and northeastern limbs, I would say, are the most likely places to see a large flare. We are seeing some plasma motions up there in the northeast especially, and a little bit in the northwest. So that's the scenario. And let's move to energetic particles and solar flares. So the ghost proton flux, we did see a little proton event. So this is a prime example here of how you can see a proton event happen without a flare to go with it. So that proton event there starting to arrive around 4:40 universal time, and no flare preceding it there. So occasionally the sun flings relativistic particles at Earth, and don't get coronal mass ejections and solar flares confused, folks. They're separate phenomenon. Let me say it again. I say it all the time on the channel. Solar flares are photons. Imagine a flashlight that's emitting X-rays, right? Photons. Coronal mass ejections are protons. Imagine standing in front of a fan. Of course, the fan would have to be blowing at hundreds of kilometers per second, but you get the idea. One is nuclei, mainly hydrogen nuclei, is the solar wind. The other one is radiation, electromagnetic radiation in the form of X-rays. Solar flares are photons. Coronal mass ejections are protons. So flaring has been low. The largest flare of the past 24 hours was actually this one, I think. Only C-class intensifications here. It's been a bit of a lull in solar activity. And if you're worried about the sun shutting down, here's a bit of a lull at that nonsense. Grand solar minimum, it's canceled. Canceled, I tell you. Here are the past 24 hours in SDO 94 angstroms. One of the best wavelengths to view flares. And at least one of those C-class intensifications did come from this sunspot group right up here, near our Earth scale. Again, the northwest and northeastern limbs are, in my opinion, the most likely place to see large flares. Let's add 131 angstroms. There's 94 plus 131. And let's talk about what's going on overhead. So here's our star chart from skyandtelescope.org. Just press the Now button after you've put in your location, and that's where things are. Mars here just peeking over the horizon here over Lehigh Valley, Pennsylvania, as the sun chases Venus and Mercury across the morning sky. Jupiter is setting over there in the west. And here is your solar system forecast. And by the way, if you're wondering why these planets are glowing, it's because those planets are in retrograde. In other words, those planets are moving in the opposite direction to the rest of the background stars. That is why the planetstoday.com shows those planets with those purple aura around them. That's why it is. They're in retrograde. They're not moving with the rest of the stars. So the planets that aren't lit up, they're moving relatively at the same speed as the background stars, whereas these planets are moving in the opposite direction with respect to Earth. They're in retrograde motion. Anyway, here's your 1 week forecast for the solar system. In 1 week, we'll be at the 25th of September, and we will have a gibbous waxing moon. Here's our astronomy photo of the day by Maxime Velez. And what she's done is she's taken a photograph of the bridge between Earth weather and space weather. Some sprites there, showing up above a normal, boring-looking tree. Note the similarities, by the way. Yeah, the similarities between that tree and that sprite. That's, I believe, what is being depicted here. And, of course, that lightning coming out of the mesosphere, well above where most Earth weather happens, way down at the troposphere level. So again, that's the astronomy photo of the day. If you want to check it out yourself, that is apod.nasa.gov. And next it's time to look at coronagraphs. And we've had a pretty chill 24 hours here. So the past 24 hours, not real extreme for coronal mass ejections. There are yesterday's CMEs. And the major one is going to be out of the southwestern limb. That's the Eugene Bagashov filament, which is still partially anchored around the southern hemisphere. We'll show you that here later in the video. Just a minor, not an Earth-directed CME there, just a minor event. That's 96 frames from yesterday, September 17th. And here are an additional 22 frames from today. So some outflows happening there. It's been pretty calm for coronal mass ejections, while a major one is on the way to strike Earth tomorrow. So here's LASCO C2 and C3. We'll also zoom in a little bit closer here. Here's the eruption of the Eugene Bagashov filament, which had a dense core, I might add. But, alas, not earthly directed. And we'll be calling tomorrow's solar storm the Tamitha-Skov solar storm, as we named that filament after Space Weather Woman. We'll also show Stereo A, and a little quick note about Stereo A. We used to really rely on Stereo A in order to be able to determine the trajectory of a coronal mass ejection, and since Stereo A has moved so close to Earth, here, check out the image. See that red circle there? That's stereo A. It's still quite in line with the Earth. Guess what's happened? It's raised my game. Because we used to very much rely on seeing stereo A to determine especially the north-south orientation of coronal mass ejections, and now we're able to do it without stereo A at all. So it's one of these things where adversity leads to better understanding of things. So anyway, just figured I'd throw that in there. Stereo A, it's almost in line with Earth. Again, there's the, and see how close it is in terms of the angle of attack there. And there's the Eugene Bagashov filament erupting from stereo A. The difference imagery on the right. I guess we'll briefly play that. Why not? There's a bunch of missing data right after that CME happens, so it's not very useful. Here you go. There's the Eugene Bagashov filament eruption. And before we talk filaments, let's show our custom videos, as they are spectacular. There's the past 24 hours. Putting together Soho Lasco C3 in blue, C2 in red, and the SDO 193 angstroms wavelength. Here's a little closer view of that. Again, part of that filament remains anchored in the southeastern limb. So filaments, they have a tendency to either eject, collapse, reposition themselves. Sometimes they'll do all three. This one mainly ejected and repositioned. So here's just 193 angstroms by itself. And you'll note in the lower right there, the southwestern limb, the ejection and repositioning of the Eugene Bagashov solar filament. We've got some other filaments that are certainly noteworthy, so let's break those out. We're going to go to the El Teide, Spain, ground-based hydrogen alpha imagery. So here it is. And the filaments that have names are this one up here. That's the Scott McIntosh filament. This is the Eugene Bagashov filament down here. Up here we've got the Reed Timmer Storm Chaser filament. There you go. So some significant filaments here remain on the Earth-facing portion of the solar disk. Part of the Tamitha-Skov filament is actually still there as well, north of this magnetically complex sunspot group. So that's some hydrogen alpha imagery. We'll also show grayscale. Because it shows prominences, that is filaments, those are filaments that are hanging off the edge of the solar disk, like these features up here. And once again, if you want to name filaments, do it on Twitter. Follow the hashtag #NameThatFilament over there on Twitter. And we will name filaments after your friends, your foes, or you can even name them after yourself. So make sure you join us over there. Thanks to our new Twitter followers. One of these years, we might even reach 500 followers on Twitter. Wow, what a milestone, folks. Isn't that amazing? Isn't that censorship? It's definitely censorship. Anyway, yeah, thanks to our new followers over there on Twitter. And we've been talking a lot about cults on Twitter. And a brief note on that. What's up with cults? Why are there so many cults, folks? I don't understand it. I mean, there are people that are in like 5 different cults at the same time. You would think there'd be a conflict of interest being involved in that many cults. What are the features of a cult, I ask? Well, they are, 1, you got to have a living leader. 2, it has to be harmful. And 3, it has to believe nonsense. All cults have all 3 of these features. A living leader, harmful, believes nonsense. There are so many cults, I can't keep track. And many of them are all intertwined. You've got doomsday cults that are intertwined in various politician cults, celebrity cults. It's crazy. I mean, there is an insane number of cults. And we're inviting you to join the cult of Eugene the Philosopher. Just kidding, folks. Eugene is not harmful. He's actually very helpful. So check out his channel if you haven't. We're trying to get him to 1,000 subscribers. He's approaching 500. If you haven't subscribed to Eugene the Philosopher, please do. As he does talk about science a bit, but he talks about all kinds of things. He's not limited to talking about science. The particle physicist from Belarus is actually crucial in my formation of my crap hypothesis on how the sunspot cycles work. Also, you may have seen Eugene on our channel. He is the top contributor to our channel. If you check out our playlist, The Diamond Anvil Too Hard to Smash, you can find several videos there featuring Eugene. So again, make sure you go subscribe to Eugene the Philosopher, Philostopher, the greatest living philosopher since the unfortunate passing of Robert de Nameland, whoever that is. Anyway, thanks to our new subscribers once again over on YouTube. And let's take a look at the last couple of hours here from the GOES 16 SUVI's perspective. There you go. There's 304 angstroms from the GOES 16 SUVI, as we're almost ready to get to our space weather bonus features segment. So there are the past about 2.5 hours as plasma hurtles toward Earth, raising the possibility of a significant geomagnetic storm, possibly even a major one. So here come bonus features. Satellite charging hazards are first. We do have some minor surface charging hazards there in the Eastern Pacific. That is low energy electrons that are building up on the outside of spacecraft. Again, they are minor surface charging hazards. No red there, just yellow. Next, the GOES electron flux here. There's the past 3 days. It's in a normal operating range. Pretty unremarkable. Here is the 1-year graph of it. And I would suspect that we'll see a huge decrease in the electron flux as the readings become anomalous. It is measured at the F layer of the ionosphere, and that puffs up so much during geomagnetic storm conditions that it'll probably show up as on the floor here, which is, again, it does become an anomalous reading during geomagnetic storm conditions. So that's the 1-year graph from Solon.info. Here is the forecast. And like we said yesterday, the most recent update there is a little bit lower than the forecast, represented by the green box. The yellow diamond is the observation. It is measured at the F layer of the ionosphere, so we'll show the vibrational frequency of the bridge between Earth and space. The F layer of the ionosphere, it's located at about 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with atmospheric temperatures, electromagnetic radiation, penetration, and chemical concentrations. Here's the F layer in megahertz. That ionogram courtesy of the Australian Government Bureau of Meteorology. And things aren't looking particularly out of the ordinary here. Here's the anomalygram. That's anomaly in megahertz from a 30-day median. We show it daily on the channel because you never know when immersing yourself in the data will yield answers to questions not asked. Answers to questions not asked. What do I mean by that? Well, what I mean is in science, everybody asks the same questions. And typically we don't end up with any answers to those questions. We just end up with more questions if we're doing it right. But sometimes we end up with answers to questions not asked. That's how I've accidentally discovered the mechanism likely underlying the solar sunspot cycles. It's pretty serious. It's the only plausible theory I can come up with. I've been trying to disprove it for a couple of years now, and I'm only finding information that supports it, not that disproves it. And believe me, I'm trying to disprove it. I don't necessarily want it to be the case. It just is. So that's how it works, folks. Answers to questions not asked. There's the latest ionogram, 12:30 Universal Time. Ionogram and 12:30 Universal Time anomalygram. We also show total electron content. It shows the likely areas for GPS errors. Feel free to pause the video on this frame if you're not familiar with distances to those things in miles. Here is the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. It's literally a count of free electrons to the inner portion of the outer van. It's literally a count of electrons from ground level to the inner portion of the outer Van Allen belt. That's about where your GPS satellite is located, at about 12,500 miles of altitude. Those are where the free electrons are. Of course, they puff up on the noon side of the planet. We also show the anomaly from the 10-day average for electron content over North America. We are seeing continued high electron count anomalies over Central America there, and Mexico. So you see the red lighting up, that's high electron count anomalies. And again, its anomaly is from the 10-day average. We'll close out our space weather section of the video as we do with the latest intensitygram and the latest magnetogram. So that's a fairly likely spot for solar flares there as that group approaches the limb. We are seeing some plasma instability there as well. These are beta gamma class sunspot groups. That one does have some minor deltas. This group down here has some minor deltas as well. It's beta gamma delta class, but just barely. This group here, that's a pretty complex sunspot group. Sweet. So that might be the most likely place for a large solar flare moving forward. It has been the most significant flare player over the past 24 hours. There are the magnetograms and so on. It's fairly large. It's fairly what's the right word? It has a disparity between the umbral size and the magnetic fields. So that's probably the best formula by itself without proximity to the limb. And it's time to move to meteorology. So once again, thanks to the Smash team. These videos are brought to you in part by the Smash team. Before we do our meteorology segment, again, take a moment to press the like button if you haven't done so. Once again, thanks to our new subscribers. Welcome to the Neo Renaissance. If you want to support the channel, the best way to do it is by becoming a member of the Smash team. You'll get additional content, and we're going to put out a video about my crap theory about the solar sunspot cycles. It's only going to be available to Gold Smash team members because at the moment, we haven't submitted the paper for peer review yet or published it. So once it's submitted for peer review and then published, everybody will have access to it and be able to hear about my crap theory. But until then, it's only for Gold Smash team members. So it's, at the moment, it's going to cost you $10, $9.99 a month because we need funding to keep these videos existent. And yeah, it's kind of costly to create the videos and and write a science paper. So anyway, smashomash.com/smash team. We even send out email alerts to bronze level Smash team members, which cost $0 a month. The silver level is $2.99 a month, so support the channel that way. Another way you can support the channel is by picking up merch. Today's featured product is Mensa, which stands for Make Earth Not Suck Again. It's part of the reason we make these videos, since Earth has been pretty sucky over the past 42 months as mankind tries to self-destruct. Of course, most people don't really want civilization to end. Most people really aren't into depopulation. And yeah, it's pretty creepy, the level of cult activity going on planet Earth. So do your part. Make Earth not suck again. It's up to you, not giant bureaucracies that can't do their own jobs or get out of their own way. The Smash News Network is doing its part to make Earth not suck again, so pick up some merch and help support the channel. Make Earth not suck again. It's up to you. The best way to get out of a hole is to stop digging. Another thing you can find below this video in the description is links to our Amazon shop. So I take magnesium at nighttime. Why? Because it makes me drowsy. So don't take magnesium with calcium. They act like co-antagonists. They reduce the efficacy of each other. So I take magnesium and zinc every other night at bedtime. I think it might help me sleep. I don't know. Some people take magnesium as a sleep aid, but of course it is important for things like bone health, and also it provides cellular protection. You can find a link to the Amazon shop. It's amazon.com/shop/smashomash. Find out which supplements I take. Again, I take magnesium and zinc every other night at bedtime. So pick up your supplements perhaps via our Amazon shop. Support the channel that way. Or perhaps visit the Hemp Lucid shop. Support the channel that way, as there are some sales going on here with sleep stacks, stress stacks, the full stack package, and immune stacks. So lots of different products there at Hemp Lucid. Again, links below this video to our Hemp Lucid affiliate/sponsor. If you see the paid affiliate/sponsor link on the YouTube video, it's because these videos do have paid affiliate/sponsors as we endeavor to keep these videos existent, publicly visible, and free for all to view. Thanks to everybody who has picked up products, whether it's merch, whether it's becoming a member of the Smash team, or whether it's at Amazon. Cheers to all the rest of you. Congratulations on realizing the channel exists. You may want to thank the Smash team for the existence of these videos. And let's move on to meteorology. We're going to start things out by looking at the world's lowest pressure. So the world's lowest pressure right now is only 950 hectopascals there in the Southern Ocean, as there are some, shall we say, chilly low conditions down there. A huge series of low pressures there south of New Zealand and Australia in the Southern Ocean. That's the world's lowest pressure at the moment. That is the mean sea level pressure, and probably not the best place to be on a boat right now in the Southern Ocean, especially that portion of it. Quite stormy down there. Besides that, pressure is pretty chill. Anyway, and that's like hurricane force pressure there is 950 hectopascals, is lower than the pressure of Hurricane Lee when it made landfall on Canada. Anyway, let's take a look at the surface winds and jet streams of the planet. There are the surface winds, rather. For the east, here are the jet streams. Jet streams of the central world depicted here. Surface winds of Europe, Africa, and the Middle East. Surface winds of the western world. And there are the jet streams. Moving right along, looking at snow depth here. I figured I would bring up snow depth. I know it could be a little controversial, but hey, what can you do? These are facts. So, Greenland, melt season is over. And if we look at new snow, snow is already falling on Greenland and in the adjacent Atlantic Ocean, I might add. So snow is going to start to accumulate. It already indeed has. There's a full northern hemisphere view. Some snow already showing up in British Columbia as well. Anyway, here are clouds and fog over the Americas. It's too dark over half that map to use a visible satellite, so we use a shortwave radiation map. Some rapid cloud nucleation happening there around Panama. And if you're wondering what that glow is, that is moon glow, as the GOES has experienced some partial lunar eclipses. It does happen around certain times of the year. Let's move on to our weather.gov map and some flooding forecasted here for New England. Also some air quality alerts still showing up, I believe, and some dense fog advisories in some areas. There's the key, weather.gov. If your location is lit, head to weather.gov. Click on your location. It's the National Weather Service homepage, weather.gov. And here's your smoke forecast, courtesy of firesmoke.ca. So heavy smoke here around Northern California and Southern Oregon. Also smoke making it all the way down into Illinois, Missouri, and indeed all the way down to Memphis. Also the Great Lakes experiencing some significant smoke. And the forecast bringing a little bit of smoke to the mid-Atlantic states here as well, courtesy of Canada. Here comes some forecasts. First, we're starting out with the GFS. That is the GFS 72-hour pressure and precipitation forecast, courtesy of tropicaltidbits.com, tropicaltidbits.com. So heavy rains here coming to New England. And you can see some snow indeed falling there in Canada. Here's your total accumulated precipitation forecast in inches for the next 72 hours based on the same model, the GFS. 72-hour GFS total accumulated precipitation in inches. And last but not least, temperature anomaly. So that's temperature anomaly in degrees Celsius, the same model, the GFS 72-hour. Next, your lightning mapper. This is the past about 10 hours of lightning. Some heavy lightning off the east coast of the southern U.S. there. Besides that, pretty calm. Here's your current lightning map. And do we have any terrestrial strikes? Let's check and see. I don't think so. Maybe in Utah, but besides that, quite calm as far as lightning across the U.S. Western Europe, less so. There's a little bit of thunder and lightning happening there. And indeed, there is a strike in Utah. Grand Staircase National Monument and Death Ridge Wilderness Study Area has some thunder rolling in. There is the location of that minor lightning activity. We'll close this video out with U.S. Doppler radar. Precipitation there subsiding in Alaska and moving into New England here in the northeast. Here's the clouds and fog view. Here's the water vapor. Cold air pushing down into Ohio here at the moment from Canada. Here's a recap as we bring you the weather from the surface of the sun all the way down to planet Earth, the lower 48. Shortwave radiation and the water vapor map. It's time to close this thing out. Thanks for tuning in. Once again, congratulations on realizing the Smash News Network, these busted name of news exists. We're frankly surprised. Whew. I've been your host, Dan, a.k.a. Smash-A-Mash, signing off. And may that solar wind be at your back.